All right, so let's look at the next example. What are our critical values? Let's stick those in here first. We've got a few different values now. So our smallest critical value is going to be -2, isn't it? Then we're going to have a critical value at 1 and a critical value at 2. So the smallest critical value is -2. It's caused by this one, isn't it? Where is this one going to be positive? Is it positive always? Is there somewhere it's not positive? Where? -2. What value does it have there? Is it negative? It's 0 there. All right, so that'll do us there. Our next one is going to be this one. Where is this one going to be positive? Greater than 1? We're going to be positive here. And the one in the denominator, where will this be positive? Greater than 2? So we have got positive, 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 negative, negative, positive, positive, negative, 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 positive. Our result right. So here in this space, it's going to be positive. Here it's going to be positive. What happens at -2? It's 0. Oops. It's 0. What about a 1? It's 0. And then between 1 and 2? Negative. And at 2? All right, sorry. So at 2, we are not defined, aren't we? And greater than 2, we're going to be positive. Now our inequality wants greater than or equal to 0. So for our answer here, we are going to need to include the zeros. So we want all of this, and then we want this bit here. Is that right?
Yes.
What inequality will express that space? We want to start with -infinity up to and including 1. And then we want to go from 2 up to and approaching positive infinity. Have a go for this one yourselves. 2 minutes for this one, it's easier. All right. So you can do this one just by looking. We want it to be negative. Now, the numerator is positive, the denominator is positive. The denominator is not defined for which value?
1.
For 1. So for what values will this be negative? None. None. So you can write, you're probably best just to write in words, x is never negative for this one. If you don't like writing with words, and you want to use symbols, I think one way of saying this one would be see that x is an element of the empty set. That's not theta, that symbol there is what we call the empty set. So there are no, it's a set with nothing in it. X is an element of the empty set. Right, so you can solve these questions using your graphing calculator. So you can draw the graphs on your graphing calculator and then interpret the result Sorry, Zahan. We'll just finish. Have a look at this question now and interpret the results with this diagram drawn on the graphing calculator. All right. So our first inequality, we want where the function is less than or equal to 0. So that's going to be in this space here and this space here. We can see on the graph. So this is going to be from -3 up to -1. And then we are going to go from 2 up to 3. Now, which parts are included? Do we include -3?
No.
Why not? Because it's an asymptote. Do we include -1?
Yes.
Yes, because the inequality wants the zeros. What about the 2?
Yes.
And the 3? No. So the positive parts of the graph. The positive parts of the graph is going to be here, and then all of this and all of this. So our inequality is going to start at -infinity. Do we include that? Why not? You never get to infinity. Do we include -3? No. Do we include -1? Why not? Because it's greater than 0, and 0 is not greater than 0, so we don't include -1. What about 2? No, we don't include that. 3? No. And then we finish at infinity. Squeeze that one in there. So, lastly, we need to be greater than 1. So we're going to use the horizontal asymptote we see there. And we want to describe for the last one this space here, and this space here. So this is going to be from -infinity up to -3. And then from 3 to infinity. All right, our bonus question. What's the function? What's the function going to be? It's going to be y is equal to, what are the roots? So we have a root at -1, which means we have the factor x plus 1. The other root is at 2, so we have the linear factor x minus 2. We could have some coefficient here. In the denominator, we have asymptotes, vertical asymptotes, at -3 and at +3. What's the value of a going to be, and how can we tell? Yes? It's going to be positive, yeah. What value? Discuss with the people next to you. Look at the graph. What is the value of A? All right, so we have the horizontal asymptote y equals 1. So A has to be 1. That's it. That's the function. Well, normally we would have the lead coefficient of the highest order term of the numerator and the denominator, like this. And if n, sorry, give this one a D. If n equals D, we get a horizontal asymptote such that y equals A over B. Well, you can always rearrange this equation so that instead of having A over B here, you could let A, the capital A, be the fraction A over B and put a 1 in the denominator. It's going to give you the horizontal asymptote that way. All right, we're finished there for today. Have a go at the practice questions.
Why wasn't E negative? Because it's affected against X.
Nope. Typically, for knowing whether A is going to be positive or negative, look to the part of the curve that where it approaches infinity. So, let me explain it a little bit here. So, if we have the reciprocal function, it looks like this. It looks like this if we have y is equal to a over x and a is positive. When a is negative, it looks like this. So y is equal to negative over positive over x. So look to the part of the graph that where it's sort of approaching the asymptote over here to see whether it's positive or negative. If in doubt, test a value somewhere. Sorry, let me just stop the video.